Good job.
Newton's laws can help explain the Newton's cradle. Newton's first law states that an object at rest will stay at rest unless acted upon by an unbalanced force. Right now the cradle is at rest, but when I lift and let it hit the others, the unbalanced force causes the resting objects to move as well. Newton's second law states that the force acting on an object is equal to the mass of the object times that acceleration. Pulling and releasing one ball applies force, causing acceleration based on its mass. However, if we add more balls and release, the mass and release, the force and acceleration would also increase if it does it right.
Cool. According to Newton's third law of motion, for every action there is an equal and opposite reaction. When one or more balls at the end of the cradle is lifted and released, it hits the ball that is at rest, transferring its momentum and energy through the ball or line of balls.
Now we can apply this information to Newton's cradle. The energy transformation relative to your hand lifting it up. So as your hand raises the ball, the outermost wall of Newton's cradle, this creates potential energy, and the higher you raise it, the more kinetic energy it will produce. As you let go of the ball, you are now using chemical energy as you are using the energy that you have gained from eating to move the ball on Newton's cradle. Now the actual movement of your hand is mechanical because it's in motion. The energy transformation relative to Newton's cradle is as the ball swings down, this creates kinetic energy because it hits the stationary ball, and most of its energy is transferred into the stationary balls, but some of it is lost because it creates sound and thermal energy. Okay, so this is how the energy transformation diagram will look relative to your hand lifting the ball. So as you lift the ball, you are using the chemical energy from where you just ate, and then the mechanical is the actual movement of your hand. And a byproduct of the mechanical energy is thermal. Okay, so this is the energy transformation diagram relative to Newton's cradle. So as I raise this ball, the higher I raise it, the more potential energy it will have. So the more kinetic energy it will have, because they have a direct relationship. So as I let go, this potential energy is going to now turn into kinetic energy. And as you can see on here, the byproduct of this mechanical kinetic energy is sound and thermal energy. That's it.
Momentum is a concept that describes the motion of an object and its resistance to changes in motion. The conservation of momentum and energy controls the motion of Newton's cradle. With the conservation of momentum, Newton's cradle demonstrates that the total momentum of a system remains constant with no external forces acting upon it. Okay. When the ball is lifted and released, the momentum is transferred down the line through the stationary balls. The final ball on the end moves away with the same momentum as the initial ball, maintaining the momentum of the original ball. The cradle also demonstrates conservation of energy because the potential energy of the ball, while the ball is being lifted, is potential. Okay, and upon release, it is converted to kinetic energy. The kinetic energy is transferred through the balls and reappears on the opposite end. Newton's third law of motion is shown when the first ball strikes the second, and it exerts a force on the second ball. The second ball exerts an equal and opposite force, causing the momentum transfer through the line of balls.